Hello, am I audible?
Yes, sir.
Right, okay. Okay, yesterday we have taken the one numerical. So all of you please draw this diagram. All of you please draw this diagram. That is deflection, slope, moment and shear as we were discussing last lecture. For this case, constant point load on the beam. So please draw this diagram. In the question paper, they are asked the derivation as well as the diagrams. In the question paper, they ask the derivation as well as the diagram. Draw the deflection, bending moment, shear. So please draw this diagram. First is for deflection. Then second is for slope. Whatever the equations we have written in yesterday's lecture. So depending upon that equation, we have to draw this diagram, right? All of you please draw a diagram, draw the diagram please. Whatever the case we have considered in the last lecture, for that case, please draw this diagram for deflection, slope, moment and shear. Already we have derived the equations. In that particular equation, we have to put the values. Y is deflection, theta is slope, mx moment, vy shear. Please draw these diagrams. Deflection, slope, bending moment and shear. After finish, please inform. By putting the value of beta z 3 pi by 4, etc. So we get the values of the slope, deflection, moment and shear. Over? Shall I proceed?
No, sir. Wait, sir.
Okay. Okay, or shall I proceed? Is it over? Shall I proceed? Yes.
Yes, sir.
Completed? Shall I proceed?
Yes, sir.
Okay. Now next condition, write down the heading only. Write down heading, semi-infinite beams with concentrated loads. Semi-infinite. Limitation on one side and on another side it is finite. Semi-infinite beams with concentrated load. Please write down the heading. Semi-infinite beams with concentrated load. Right now for this again we have to find out the deflection, shear, bending, slope, semi-infinite beams with concentrated loads, right? Suppose we have considered this beam, horizontal axis is your x-axis and vertical axis is z, and W is nothing but suppose W is nothing but your delta or y, W is nothing but deflection. W is nothing but deflection, that is we have taken as y, or you may call it as delta also. W is called as a deflection, right? So this beam we have considered, okay, which is on positive x-axis, right? Positive x-axis, and at origin, okay, that is x equal to 0, x equal to 0 to infinity, infinity, that is called as a semi-infinite. Okay, that is called as semi-infinite. Okay, at one end there is a limitation, that is x equal to 0, that is we have placed at origin, and on other side there is on positive side, okay, there is infinity values of x, infinite values of x, right? Then the load P naught is applied at origin, and there is a moment m naught which is clockwise, okay, which is acting at the end where x equal to 0. Okay, this is the beam, rectangle beam, right? At origin we have applied the load, that is P naught and m naught. Then whatever the resulting deflection W, Y or delta, okay, meaning एकच सगळ्यांचं एकच आहे. तुम्ही लेटर कुठलं यूज करा, सिम्बॉल कुठलं यूज करा, meaning is same. W, Y or delta, that is deflection. Okay, so at x equal to 0, that is at origin, the resulting deflection and slope will be W naught. Why W naught? Because at x equal to 0, the value of deflection is W naught, and at x equal to 0, value of slope is nothing but theta 0, that is theta naught, right? Which is both are positive in the sense which is shown in this figure. So any of the loads and the deflection may be negative in the particular numerical cases. Okay, so we have to consider, okay, W naught rather than P naught or the theta naught rather than the M naught, right? So we have to find out W, that is deflection. We have to find out slope. We have to find out M. We have to find out shear force in the beam as a function of X. So as we have taken the load P naught and M naught at the origin X equal to 0 and limit of X naught, sorry, limit of X is from 0 to infinity. Okay, limit of X is from 0 to infinity, that is called as semi-infinite. So for this beam, we have to find out now deflection, slope, moment and the shear as we have done in a last case. So you can see the figure. Okay, this is the beam which is subjected by concentrated load P naught M naught at the end of semi-infinite beam on the Winkler foundation, and end deflection W naught, whatever the end deflection W naught at x equal to 0, and whatever the slope end rotation theta naught, okay, that is nothing but rate of change of deflection at x equal to 0, okay, which is both are in positive sense. Now, because of deflection W or Y or delta, because of deflection, okay, which must vanish at x equal to infinity. Okay, as x is 0 to infinity, so the deflection must vanish at x equal to infinity. Okay, so as per the equation of the deflection, that we have seen in the last lecture, we have derived the equation of the deflection, that is y, okay, in terms of the C1, C2, C3, C4 sine cos E beta Z plus or E beta Z minus, okay, depending upon this equation of the y or w or delta, y, w or delta, okay, so we have to use this equation, and at x equal to infinity, okay, that is e raised to beta x, then cos beta x plus sine beta x plus e raised to minus beta x, like that. So in that equation, we have to put the value of x is equal to infinity, x equal to infinity. Okay, we have know this equation of the w, or we know the equation of w or y. So in terms of e beta x, c1 sine beta x plus c2 cos beta x plus e raised to minus beta x, c3 sine beta x plus cos beta x. In this equation, we have to put the value of x is equal to infinity. X is equal to infinity, we have to put the value of x equal to infinity. Then we have to find out the constant, that is c1, c2, right? So by x equal to infinity, so c1 and c2 is equal to 0. By putting the value of x equal to infinity, we get c1, c2 is equal to 0. And two more conditions are needed because there are two unknowns, c3 and c4. Okay, as x equal to infinity, c1, c2, 0. So remaining are c3 and c4. So for that, we required again two more conditions to derive the values of c3 and c4. So for that, we have to take the equation of moment and the load, right? We have to take the equation of moment and the load. Moment is nothing but rate of change of slope, and slope is nothing but rate of change of deflection. Slope is nothing but rate of change of deflection, and moment is nothing but rate of change of slope. So moment is nothing but double derivative of slope. Okay, we have discussed this. So moment is equal to double derivative. So moment m naught, y m naught is nothing but moment at x equal to 0. Okay, so is equal to ei d2w by dx square at x equal to 0, and load, okay, So minus P naught is equal to minus EI d cube W by dx cube, right? That is at x equal to 0. So now we know the equations of A beta Z, B beta Z, C beta Z, D beta Z. We have discussed that equations in last lecture also. Okay, these are the equations of your A beta Z, B beta Z, C beta Z, and D beta Z. We have to use these equations for calculating the values of C3 and C4. Then again, we have to use this equation of deflection. We have to use the equation of deflection, right, for finding out the values of C3 and C4. So by using that equations and by taking the double derivative of w, by taking the triple derivative of w, that is deflection or y, double derivative of deflection and triple derivative of deflection, okay, and referring the a beta z, b beta z, c beta z, and d beta z equations, but then again taking the derivatives of the a beta z with respect to x, taking the derivative of b beta z with respect to x, taking the derivative of c beta z with respect to x, then taking the derivative of d beta z with respect to x. So by using the equations, we have to find out the value of C3 and C4. So C3 we get 2 beta square m naught by k, and C4 is equal to 2 beta p naught by k minus 2 beta square m naught by k, right? So k is a constant. So we get the value of C3 and C4, and C1 and C2 is equal to 0, right? अल्टिमेटली काय करायचं आपल्याला बाउंड्री कंडिशन्स यूज करायचे आहेत. बाउंड्री कंडिशन्स यूज करून जे कॉन्स्टंट आहेत C1, C2, C3, C4 ते त्याच्या व्हॅल्यू फाइंड आउट करायचे आहेत. त्यानंतर मग तुम्हाला एक इक्वेशन भेटेल कुणासाठी डिफ्लेक्शन, स्लोप, मोमेंट आणि शियर बाय पुटिंग द व्हॅल्यू ऑफ C1, C2, C3 and C4. ठीक आहे. Ultimately, what is our aim? By using the boundary conditions, we have to find out the constant C1, C2, C3, C4. For that, we have to use the equation of moment, load, slope, deflection, shear, etc. We have to use the equations, and then we have to putting the boundary conditions. Then we have to find out the constant C1, C2, C3, C4. So right, so C1, C2 are 0, and C3 is your 2 beta square m naught by k. C4 is 2 beta p naught by k minus 2 beta square m naught by k. So we get the values of C1, C2, C3, C4. Now, in the equation of the slope, deflection, moment and shear, now we have to put the values of C1, C2, C3, C4 by taking the derivative single or double derivative or derivative 3 times, right, of the deflection. So, as we know the value of C1, C2, C3, C4, so put that values of the C1, C2, C3, C4 in the equation of Y or deflection delta or W. So C1, C2 automatic 0, so first term is gone. Okay. So last we get the value of deflection is equal to, for semi-infinite case, we get the value of deflection is equal to 2 beta p naught. P naught is the applied load at x equal to 0 divided by k is constant into d beta z minus 2 beta square m naught by k c beta z, right? So these are the values of your, this is the values of your deflection. Now, what is slope or rotation? It is the rate of change of deflection. What is slope or the rotation? What is slope or the rotation? That is the rate of change of deflection. Now, taking the derivative of deflection with respect to x, okay, this is the equation of W. So we have to take the derivative of the W with respect to x, right? So we get the value of theta is equal to minus 2 beta square p naught by k a beta z beta x plus 4 beta cube m naught by k d beta x, right? Now moment equation, take the double derivative of w, we get the equation of bending moment m is equal to minus p naught beta b beta x plus m naught a beta x. Now, taking the triple derivative of the deflection, we get the shear force, we get the shear force. So V is equal to minus P naught C beta x minus 2 beta m naught B beta x. So these are the four equations. These are the four equations. First equation is for deflection. Second equation is for your slope. Third equation is for moment. And fourth equation is for shear. Right? So from this equation, for semi-infinite case, by using these equations for semi-infinite case, x is 0 to infinity, right? We have to find out the values of slope, deflection, moment, and shear, right? So all of you, if you have written the title of the case, that is semi-infinite beams with concentrated load, okay, please draw the diagram and then we have to write down the equations, that is last equations. Please draw these diagrams. Please draw these diagrams. It is a matter of finding out the constant C1, C2, C3, C4 by using the boundary conditions. That's why in the syllabus also it is mentioned semi-infinite case or finite case, etc. So for that condition, by putting the boundary condition, that is values of x, we have to find out the equations of deflection, slope, moment, and the shear. Please draw these two diagrams, and below that write down these terms. First figure ला नाव द्या. A फिगरच्या खालती त्याचं डिस्क्रिप्शन लिहा आणि बी फिगरच्या खालती त्याचं डिस्क्रिप्शन लिहा. For solving the numericals, we require the equations. So for that, we have to write down the equations of deflection, slope, moment, and shear. Diagram is over. Please write down the description of figure A and figure B. Below that particular figure, you have to write down the description. After finish, please inform. After finish, please inform. Okay, shall I proceed?
Yes, sir.
Shall I proceed?
Yes, sir.
Okay. Please write down the equations of deflection. You may call Y or delta or W. You may call Y, delta or W for deflection. So delta or y or w is equal to, write down the equation of deflection, 2 beta p naught by k d beta x minus 2 beta square m naught by k c beta x. After finish, please inform. Is it over? Shall I proceed?
Just a minute, sir.
Yes,
Okay.
sir.
Done, sir.
Okay. So please draw these diagrams for deflection moment due to the n force and due to the n moment. Curve, deflection curve and moment curve, deflection curve and the moment curve. Okay, there are sine and cos in terms in the equation of a beta z or a beta x, b beta x, c beta x, d beta x. हे जे इक्वेशन आहेत ए बीटा एक्स बी बीटा एक्स सी बीटा एक्स आणि डी बीटा, या इक्वेशन मध्ये तुम्हाला साइन कॉस भेटेल. ओके, तिथं बीटा एक्स आहे बाय पुटिंग द व्हॅल्यू ऑफ एक्स, बाय पुटिंग द व्हॅल्यू ऑफ एक्स, right, from x equal to 0 to x equal to infinity, by putting the value of x equal to 0 to x equal to infinity. Okay, at somewhere you get the value maximum, at somewhere you get the value 0. So for deflection, deflection is equal to 0 when x equal to pi by 2 beta. X equal to pi by 2 beta, and moment is maximum at x equal to pi by 4 beta. After finish, please inform so that I will proceed.
Done, sir.
Okay. Now take the numerical. Numerical. A semi-infinite steel bar. Take down the numerical. Take down numerical. Semi-infinite steel bar E is equal to 200 GPa, that is 2 into 10 raised to 5 Newton per mm square. Semi-infinite steel bar. Semi-infinite steel bar E is equal to 200 GPa, has a square cross section, has a square cross section, 80 mm on side, square cross section, 80 mm on a side, and rest on Winkler foundation, rest on Winkler foundation of modulus K naught is equal to K naught is equal to 0.25 Newton per mm square per mm. K is equal to 0.25 Newton per mm square per mm. Full stop. A downward force of 50 kilonewton, a downward force of 50 kilonewton is applied at the end. A downward force of 50 kilonewton is applied to the end. Downward force of 50 kilonewton is applied to the end. Full stop. Full stop. Find the maximum and minimum deflections. Find the maximum and minimum deflection and their locations. And their locations. Full stop. Also find the maximum flexural stress and its location. Also find the maximum flexural stress and its location. Stress is nothing but m by I into y. Flexural stress for maximum moment, or we have to find out maximum stress, flexural stress, m by I into y. Y is nothing but c. Right? That is square, it is there. Also find maximum flexural stress and its location. Now listen, We know this equation. K is equal to K naught B, where B is nothing but the width of the beam. Okay. And the K naught value for soil, okay, which is in the range of this range, 20 into 10 raised to 6 Newton per meter square per meter to 200 into 10 raised to 6 Newton per meter square per meter. Okay. So B is nothing but it is a square, so it is 80 mm. That is 0.8, right? 0.8. So by using this condition, now we have to find out the constants. Madam, solution, necessary constants are find out EI. E is 200 into 10 raised to 3, that is GPA. So 2 into 10 raised to 5 into it is a square. So whatever the square side is there, that is into 10 raised to 4th. BD cube. B and D are same. So D fourth by 12. So check whether it is correct. Check whether it is correct.
Yes, sir.
Right, okay. Then K is equal to B into K naught. So we are putting in terms of mm only. So 80 is nothing but it is a square side. Whatever the section which is given, cross section which is given, having some dimension. Okay, now it is square, therefore directly we have taken the 80. If it is a rectangle, then we have to take the width B, right? So K is equal to 80 into K naught. K naught is given 0.25. K naught is given 0.25 in mm. It is in mm. Okay, Newton per mm square per mm. So 80 multiplied by 0.25, whether it is 20.
Yes.
Right. Now next term that we have to find out beta. As you know, beta is equal to, or beta fourth is equal to, beta fourth ची value काय होती k by 4 ei. So we have to find out the value of beta. So take the fourth root of this, that is fourth root. So find out the value of beta. Check whether it is 0.001645 per mm.
Correct, sir.
Okay. Okay. Now, we know the equation of W for this case, semi-infinite case. Right? Please write down. Deflection, write down. Deflection for semi-infinite beam. Deflection for semi-infinite beam. Deflection for semi-infinite beam, you may call Y or W or delta, is equal to 2 beta P naught by K d beta x minus 2 beta square m naught K C beta x. 2 beta p naught by k d beta x minus 2 beta square m naught k by k into c beta x. Written, Tala? Next line. At x equal to 0, at x equal to 0, at x equal to 0, w is equal to 2 beta p naught d beta x by k and d beta x equal to 1 and d beta x equal to 1, d beta x equal to 1, d beta x equal to 1. So therefore, w max is equal to w naught, w max is equal to w naught is equal to 2 beta p naught by k. At x equal to 0, you get the maximum deflection. So W max equal to x naught, sorry, W max is equal to W naught is equal to 2 beta P naught by K. So put the value of beta P naught and K, check whether it is 8.225 mm or not. Whether it is correct, 8.225,
Yes, sir.
right. So next line, this is your maximum deflection. Now we have to find out the minimum deflection. Okay, so minimum deflection which will occurs, minimum deflection which will occurs at the smallest value of x for which theta is equal to 0, that is slope is equal to 0, that is rotation is equal to 0, right? For this, okay, there is one table is there, that is value of beta x depending upon the value of theta, then we have to find out a beta x, etc., etc. Okay, right down. So minimum deflection occurs at small value of x for which theta is equal to 0. Minimum deflection occurs at smallest value of x for theta is equal to 0. Right? Then next line add on, the equation of theta is equal to, add on next line, equation of theta is equal to minus 2 beta square p naught by k a beta x plus 4 beta cube m naught by k d beta x. Add on this equation of theta. as you have written already. So now for this, that is the various values of theta, sorry, beta x, for various values of beta x. Okay, so these are the values which is given for a beta x, b beta x, c beta x, and d beta x. This PDF already I have shared with you. So if you consider the different values of the a beta x, right? So at 0, a beta x is 1, b beta x 0, 1, 1. So like that at pi by 4, at pi by 4, right? At pi by 4, the value of a beta x is 0.6648, 0.3324, c is beta x 0, then d beta x is 0.3324, then at pi by 2, at 3 pi by 4, at pi, at 5 pi by 4, at 3 pi by 2, at 2 pi, right? So by using this table, we have to take the values of the constant a beta x, d beta x, because in the equation of the theta, there are two terms, one is a beta x and d beta x. So by referring this table, we have to consider the value of a beta x and d beta x. Right on? For smallest value, this is already written, right? So at x equal to, sorry, at b, sorry, beta x equal to 0, at beta x equal to 0, a beta x is 0. Okay, from table, at beta x equal to 0, at beta x equal to 0, a beta x equal to 0, right? So at beta x equal to 3 pi by 4, at beta x equal to 3 pi by 4, right? We will check in the table. We will check in the table. Okay, you can see here at 3 pi by 4, at 3 pi by 4, okay, a beta x equal to 0, a beta x equal to 0, and at beta x equal to 0, a beta x equal to 1, right? So at 3 pi by 4, at 3 pi by 4, when beta x equal to 3 pi by 4, a beta is equal to 0. So you can see here at 3 pi by 4, a beta is 0, and we have taken the value of d beta x minus 0.0670 again in the table. At beta x equal to 3 pi by 4, a beta x is 0, and d beta x equal to minus 0.0670, minus 0.670 at at beta x equal to 3 pi by 4, a beta x is 0, and d beta x is minus 0.067. Okay, these two values we have considered for further calculation. Write down. All of you write down, please. Okay, write down at beta x equal to 3 pi by 4, at beta x equal to 3 pi by 4, at beta x equal to 3 pi by 4, टेबल जरी नसला, टेबल जरी तुमच्याकडे नसेल तर तुमच्याकडे ए बीटा एक्स, डी बीटा एक्स, सी बीटा एक्स आणि बी बीटा एक्सचे इक्वेशन आहेत जे तुम्ही काल लिहिलात. Yesterday we have written the equations. So in that you can put the value of beta x equal to 3 pi by 4. ओके, त्या इक्वेशन मध्ये जर तुम्ही बीटा एक्स ची व्हॅल्यू 3π/4 पुटअप केला तर यू गेट these values of a beta x and d beta x. Here we not need the table, but we need the value of beta x equal to 3π/4. Around at beta x equal to 3π/4, a beta x equal to 0 and d beta x equal to minus 0.0670. Right? Yes, done? Shall I proceed?
Yes.
All right. Now, in the previous calculation, we know this equation of W. You can see here as a beta x is automatic 0 in the equation of theta. So remaining term is only d beta x. So W minimum is equal to whatever this equation multiplied by d beta x value, right? D beta x value. So write down minimum deflection W minimum deflection W minimum is equal to 2 beta P naught by K into d beta x, right? So put all the values, that is beta P naught K, put all the values beta P naught K, you get this value of W minimum, that is minus 0.551 mm. Check whether it is correct or not. Put the value of beta P naught and K.
Correct, sir.
Okay, okay. Now the values of your deflection is known to you now. Next line. Next line. Write on this equation. Write on this equation. M is equal to, that is for bending moment. Write on this equation. M is equal to minus P naught by beta b beta x plus M naught a beta x. M is equal to minus P naught by beta b beta x plus M naught a beta x. As for the this case, we get the value of a beta x equal to 0. A beta x equal to 0. So this second term will automatic is equal to 0. So remaining only this term minus P naught by beta into b beta x. Okay, so next line as the equation we have written. Next line. Okay, next line as a beta x equal to 0, a beta x equal to 0, a beta x equal to 0. So next line M is equal to minus P naught b beta x by beta m is equal to minus p naught b beta x by beta. Now we have to find out maximum bending moment. Okay, maximum bending moment. For that, we require the maximum value of beta x, sorry, b beta x. We require the maximum value of b beta x. Okay, we require the maximum value of b beta x for getting the maximum bending moment. So we have to consider the largest magnitude of the b beta x. We require the largest magnitude of b beta x. So at what value of b beta x? At what value of beta x? At what value of beta x we get the maximum value of b beta x? At what value of, that is, at what maximum value of beta x we get the largest magnitude of b beta x? So for that we have to refer the table, or at beta x equal to pi by 4 we get the maximum value of b beta x. So we will refer the table. So second term is your b beta x. So we have to refer this table for getting the maximum value of b beta x. Now if you refer this, so it is 0.3224. We will check another value also, whether some values are greater than 0.33224. No. So if you refer these values, so this will be the maximum value of b beta x. This one will be the maximum value of b beta x, and which will be at beta x equal to pi by 4. So at beta x equal to pi by 4, we get maximum value of b beta x is 0.3224. So next line, add on. For largest magnitude of b beta x, for largest magnitude of b beta x, for largest magnitude of b beta x, comma, at beta x equal to pi by 4, at beta x equal to pi by 4, which is quarter wavelength, wavelength pi by 4, pi by 2, 3 pi by 4, and pi, like that. Beta x equal to pi by 4. So b beta x equal to 0.3224. If you refer the equation of b beta x and putting the value of beta x equal to pi by 4, you get this value also, same. Use the equation of beta x, which is written yesterday. So putting the value of beta x equal to pi by 4 in that equation, you get the value of b beta x equal to 0.3224. All of it written. So put the value of b beta x, p naught and beta, and find out the moment. Consider the equation of moment and put the values and find out the moment value. Check whether it is 9.8 into 10 raised to 6 Newton mm. Is it correct?
Yes, sir.
Right. Now, last part, which is asked in the numerical, that is stress. So, bending stress, M by I is equal to stress by Y. So, Y that is considered as a C. So, write down stress is equal to M into Y bar. You may call Y bar or you may call C, that is centroidal distance, divided by I. M by I is equal to F by Y. That is so stress is equal to M is 9.8 into 10 raised to 6 into Y bar is 80 by 2. Dimension of the square is 80, 80 by 2 divided by the moment of inertia d fourth by 12. So check whether it is 115 Newton per mm square. Yes, whether it is correct?
Yes, sir.
Right. So that is the answer. Find out the maximum flexure stress. Now its location, that is the last part, which is asked. Its location, where we get the maximum stress, at what location we get the maximum stress. So write down at x equal to pi by 4 beta, at x equal to pi by 4 beta, so at x equal to pi by 4 beta is equal to 477. Beta value is known to you. From that you get the value of x equal to 477 mm. So write down maximum stress appears on the top of beam. Maximum stress, that is 115. Maximum stress appears on the top of beam at x equal to 477 mm from the end. हे बघा हे इक्वेशन आहे ऑलरेडी बीटा एक्स इक्वल टू पाय बाय 4 तर एक्स इक्वल टू काय घेतलं पाय बाय 4 बीटा पाय बाय 4 बीटा दिस इक्वेशन कारण आपण मॅक्झिमम व्हॅल्यू फाइंड आउट केलं मोमेंटची कुठे बीटा एक्स इक्वल टू पाय बाय 4 ला मग मॅक्झिमम स्ट्रेस आला आणि ते कुठं आलं तर एक्स इक्वल टू 477 mm आलं फ्रॉम द एंड. Yes, done.